Chapter 5 is all about triangles and some relationships in triangles. In the first section, we're going to talk about just some basic information about triangles and then specifically what it means to be a mid-segment of triangle and how you can find that measurement. A triangle, as you know, is a polygon that has three sides. Every triangle will have 6 measurable parts. You can measure the 3 angles and the 3 sides. The angles would be measured with a protractor. You would measure it in degrees. The sides would be just segment lengths. You would measure those with a ruler. Every triangle can be classified by its angle measurements. We can talk about equiangular, acute, obtuse, or right. Equiangular means that every angle in the triangle would be congruent. The symbol for congruent is an equal sign with a little squiggle above it. You might have some markings on there, little arcs in each corner to show you that all 3 of those angles are equal to each other. Acute triangle, all angles would be less than 90 degrees. So maybe I have a 50-degree angle, a 60-degree angle, and a 70-degree angle. Each one of those is less than 90, so each angle is acute, the triangle is acute. Obtuse, you have one angle larger than 90 degrees. So maybe this angle is 110 degrees. The other 2 would be acute, less than 90, but this one's over 90. A right triangle, of course, is a triangle that has one angle that is exactly 90 degrees. So they might have the little square in the corner to show you that. You can also classify a triangle by its sides. We have equilateral, isosceles, and scalene. Equilateral, all sides are congruent. Isosceles, 2 sides are congruent. So maybe I have singular tick marks on those 2 sides, but a double set of tick marks down here to show it's a different measurement. Scalene, no sides are congruent. So I don't have any tick marks to show me that any sides are the same length. All right. In a triangle, we can talk about the interior and the exterior angles of a triangle. So the interior angles of a triangle, of course, are inside the triangle. So if I call this angle 1 down here, angle 2, and angle 3, those are all interior angles. Every triangle will have 3 interior angles. The exterior angles are the angles outside the triangle if you extend a side. So I kind of showed here where I took a side and I made an arrow going out from each side. Well, an exterior angle then would be one on the outside right next to it. It forms a linear pair with an interior angle. So measure angle 2 and angle 4 would add together to give you 180 degrees. We could do one down here, angle 5. It's an exterior angle because it forms a linear pair with angle 3. There's another one over here, angle 6. So it's when one side is extended and it will form a linear pair with an interior angle. So angle 4, angle 5, and angle 6 are all exterior angles. And it doesn't matter which way you extend that line, that side. For instance, I could make it go this direction. And the angle that is right here, I can call that angle 7. It's also an exterior angle because it forms a linear pair with angle 2. The next concept we're going to review, which you should already know, is the triangle angle sum theorem. The sum of 3 angles in a triangle is always 180 degrees. So if I call this corner angle 1, this one angle 2, and this one angle 3, if I measure this little corner with a protractor, and this corner with a protractor, and this corner with a protractor, and add them together, it will always equal 180. You can use that concept if you know two angles of a triangle. You can use that to find the third measurement of an angle in a triangle. Or we might use it when we have some variables in algebra. It says find the value of x and the measure of each missing angle. So I have the three angles P, Q, and R of a triangle, and I want to figure out what their angle measurement is, but I have variables. So I know that the triangle angle sum theorem says that the measure of angle P plus the measure of angle Q plus the measure of angle R will equal 180 degrees. So I can take each of my variable expressions here and substitute it into this equation. Angle P is 2x minus 9. I add to that angle Q, 2x plus 4. Add to that angle R, which is x. Now I can solve the equation and figure out what x is. All of these things are on the same side of the equal sign, so I need to add my like terms. 2x plus 1x is 5x. Negative 9 plus 4 is negative 5. Now if I add 5 to both sides, I have that 5x equals 185. And then if I divide both sides by 5, I get that x equals 37. So I can put that in the blank. X equals 37. But now I want to find the exact angle measurements. So I just go back and plug 37 in here. 2 times 37 minus 9. 2 times 37, 74. Subtract 9, I get 65. So the measure of angle P is 65 degrees. Measure of angle Q is 2 times 37 plus 4. Well, we already said 2 times 37 was 74. Add 4 to it, I get 78 for angle Q. And then angle R is just plain old x. So it's 37 degrees. You can double check your answer by adding those three amounts together and see if it adds up to 180. All right. Next concept, triangle mid-segment. Okay, so it says mid-segment. This is going to have to do with line segments. A mid-segment is a segment connecting the midpoints of two sides of a triangle. We have a theorem about it that says mid-segment will be parallel to the third side, and it's going to be half as long as that third side. All right, so let's label our sides of the triangle. First of all, let's give it some vertices. Point A, point B, and point C will be the vertices. So if we're going to have a mid-segment, it's a segment that connects midpoints of the sides. So I need to eyeball here. Midpoint is halfway in between. I'm going to call that point D. Put little tick marks on either side to show that AD is congruent to DB. So I know it's a midpoint. I can put point E down here. It's going to be halfway between A and C. So I'll put 2 tick marks on either side of that. And then I can do point F, another midpoint. I'll put 3 little tick marks here, 3 little tick marks here. So BF is congruent to FC because those are midpoints. All right, so now we actually have to draw in a segment that is the mid-segment. A mid-segment connects to midpoints. So I'm going to connect the 2 midpoints of sides AB and BC. So I'm going to make a segment DF. It's a little bit off. My F is not very good. My F should be down a little bit further. So DF is going to be parallel to side AC. That's what that theorem said. DF is going to be parallel. If it's connected in the mid-segment, it's going to be parallel to it. Okay? The other thing deals with the length of it. The length of DF will be half as long as AC. So if AC is 20, DF is 10. We could also think of it that the side AC will be twice as long as however long DF is. So if DF is 12, AC is 24. All right, let's do some problems. In each triangle, M, N, and P are midpoints of the sides. Name a segment parallel to the given line. Okay, so if they are mid-segments, or if they're midpoints, then I know that MN, NP, and MP are all mid-segments. So CD is this side here. Which mid-segment is it parallel to? Well, it's going to be parallel to MN. Oh, that's not, I can't even read. Sorry about that. Let me erase that. Try that again. Side CD is parallel to which mid-segment? PN. And it doesn't matter whether you call it PN or NP. The segment is the same segment no matter which endpoint you put first. All right, now on this one I have segment QS. Which mid-segment is parallel to QS? This one right here, NN. Again, you could call it MN. All right, example 2, we want to find the missing link. All right, we're given CD. No, we want to find CD. We know that segment ZX is 16 units long. CD is a mid-segment because C is a midpoint. I know it's a midpoint because XC is congruent to CY. I know D is a midpoint because ZD is congruent to DY. So since it's the mid-segment, CD will equal 1/2 of XZ. But I know that XZ is 16. So what's half of 16? 8. KJ, this time we want to find the mid-segment again. Okay? It's a mid-segment because we know AK is congruent to KB, we know BJ is congruent to JC, okay? And then this other side, AC, is a 18. So KJ, the mid-segment, is half of side AC. I want to find KJ. It's half of 18. 1/2 times 18. Half of 18. 9. If you want to do that, if you remind you of your fraction rules, if you do 1/2 times 18, you would put 18 over 1. 1 times 18 is 18. 2 times 1 is 2. 18 divided by 2 is 9. Okay? So guys, anytime you just have half of something, divided by 2. All right, this time, got a little more work to do on this one. So I know that N, P, and M are all, or at least N and M. Actually, I should probably have some tick marks down here to show that that one is midpoint as well. All those are midpoints. So I have NM is a mid-segment, NP is a mid-segment, NP is a mid-segment. Okay, this time, I only have from S to P. It is 8. And I want to find out how long NM is. Well, NM is a mid-segment, so it's going to be half as long as SQ. Okay, well, how long is SQ? Well, if this is 8 here, from here to here has to be 8 as well. So NM is going to be equal to half of 16. Again, half of 16, 8. Divided by 2. Okay, another example. Example 3, find the missing measurements. So this time we've got some algebra. So we have that YW is x plus 9. We have QR is 2x minus 3. Okay. QR is the mid-segment. Okay, QR is the mid-segment. We know that because YQ is congruent to YX. We've got little tick marks. YWR is congruent to RX. So my equation is going to be QR equals 1/2 of YW. All right, QR is 2x minus 3, so I'm going to put that in there for QR. That will equal 1/2 of YW, which is x plus 9. Now, to solve this equation, you could apply the distributive property and multiply 1/2 times x and 1/2 times 9. And if you do that, you're going to have fractions, you're going to have decimals. I would not do that. If this is half as long, 1/2 times, what you can do is multiply times 2 on each side of the equal sign. Because then if you take 1/2 times 2, those undo each other and it cancels out. So you can say 2 times my 2x minus 3 equals x plus 9. And you get 4x minus 6 equals x plus 9. Subtract x from both sides, and you get 3x minus 6 equals 9. Add 9 to both sides. Sorry, not 9. Add 6 to both sides. Green works. 3x equals 15. Divide by 3. X is equal to 5. And you get 5 here. You want to know how long YW is, so you have to do 5 plus 9, and you get 14. You could do a double check. If you put 5 in here for x, 2 times 5 minus 3, 10 minus 3 is 7. So QR would be 7. Is that half of 14? It sure is. All right, next example. ZY is a midsegment. So ZY is going to be half of, and we know it's a midsegment because CZ is congruent to ZR. So Z is a midpoint, Y is a midpoint. ZY is going to be half of SQ. So ZY, I plug in x plus 2 equals 1/2 times 3x minus 8. Okay? This time I'll just do this one using the distributive property so you can see how that works with fractions. X plus 2 equals, well, 1/2 times 3 would be 3/2. 1 times 3 is 3, 2 times 1 is 1. 3/2 x. 1/2 times -8 would be -4, because you have to put 8 over 1. 1 times 8 is 8, 2 times 1 is 2, 8 divided by 2 is 4. Next thing is, I would subtract x from both sides. You get 2 equals, well, 3/2 minus 1, put that up here, 3/2 minus 1 is the same as 3/2 minus 2 over 2. 3/2 minus 2/2 is 1/2. So I have 1/2 x minus 4. Now I add 4 to both sides. I get 6 is equal to 1/2 x. Now, how do I get rid of that 1/2 x? I can multiply times the reciprocal, 2 over 1. 2 over 1 times 6 is 12. So I get 12 for x. Now I want to figure out what ZY is. 12 plus 2 is 14. I can double check that by putting 12 in here for x down here. 3 times 12 minus 8. 36 minus 8 would be 28. So this is 28. This is 14. It's half as long. So that works. All right, your assignment is 5-1 in Math Excel, and you need to show work on problems 4, 6, and 9.